Today we are talking about the pH scale, which measures how strong an acid or a base is. It goes from 0 to 14. Acids are on the 0 to 6.9 part, and then bases are 7.01 to 14 portion. Anything that is 7 is neutral. It's not an acid or a base. Many of you are familiar with acidic foods like tomatoes or pineapples or strawberries or oranges or limes or lemons. There are some other acids and some other bases being the opposite of an acid that we're going to talk about today. So we're actually going to go over on this side, top right. Your paper looks a little bit different from this. This is the online Google Doc digital version. You have the same information on yours. It's just that the formatting is slightly different, but it's essentially the same thing. So the first one, the strength of an acid or base in a solution, it's the second blank, is measured on a scale called a pH scale. It spans from 0 to 14, oops, 17, 14. The middle point with a pH of 7 is neutral, which means that it's neither acidic or basic, meaning it's not an acid or a base. Oops, basic. Okay. Any pH number that is greater than 7 is considered to be a base. Any number that is less than 7 is considered to be an acid. 0 is going to be the strongest acid, and 14 is going to be the strongest base. So the extreme ends, 0 and 14, are the really, really strong things that can burn you, and then the things that are more in the middle are very weak, and they are, in general, not going to be dangerous to your skin or your body. So we're going to cover the acid section first. So over on the top left, acids are going to be ionic compounds. So they're a compound that have either a positive or a negative charge, meaning they've gained or lost electrons, things that were on the periodic table. And they're going to break apart in water to form hydrogen, H+, positive ions, hydrogen in water. Any kind of food that's going to be an acid is going to have a sour taste. They're going to react with a metal, which means they can corrode the metal and damage it. So they're very strong acids can burn your skin. And then there's this stuff called litmus paper. It's literally a strip of paper. If you take the blue litmus paper and you dip it in an acid, it's going to change it to red. Okay, that is the acid section. So when we're talking about common acids that you've heard of, we're going to start, so the middle I'm going to tell you is water, right? Pure water, straight water is neutral. It is not an acid or a base. It is perfectly, gentle on your skin. It's good for your body. It is what it is. So then we're going to go to a level 6. And your saliva, and again, there are other examples that are a level 6, but this is just one example. Your saliva in your mouth has a little bit of power to digest food in it, so it's going to be slightly acidic. A level 5 is going to be black coffee, straight black coffee, not creamer or sugar in it, because that will change the pH. A level 4 is going to be acid rain. A level 3 is going to be a soft drink like your soda. So this is a moderately strong acid. Lemon juice is a 2. Stomach acid is a 1. It's very, very dangerous for your skin. It's inside of your body. Your stomach has a mucus lining that keeps the acid from burning you. However, if you know somebody with ulcers, they are going to have basically spots in their mucus lining that's missing, and that's why they're getting having problems. Battery acid is a level 0 from like a car battery or something. Okay, so those are your acids, and anytime you move up or down a level, we are 100 times stronger or weaker. So it's not just like one little quick change. This is a drastic difference. So black coffee is 100 times more acidic than saliva. Saliva is 100 times weaker than black coffee. So when we go from 7 to 0 in this arrow here, I'm going to type. So these are stronger acids going towards the top, meaning they're going to have a lot more H plus ions. They're going to have a lot more H plus ions. Okay. So that's the top section. If you miss any of that, please pause the video and go ahead and fill in any information that you are missing. I'm going to go ahead and move on to the bottom part. So the bottom part is the base section. So we're going to be filling in right here. Bases are, again, ionic compounds, and they're going to have, again, a positive or a negative charge that breaks apart in water to form, this time we're going to be making hydroxide ions, which is going to be OH minus. It's a different kind of compound that we're forming here. It's called hydroxide. Bases are, if you have a food that's a base, it's going to have a very bitter taste, not a sour taste. They feel very slippery. These are typically your cleaners. And strong bases can burn your skin, just like strong acids can. And this time we're going to take the little strip of paper, and it's going to be red this time. The red litmus paper, if you dip it in the base, will turn blue. Okay, so those are your bases. As far as the litmus paper is concerned, if you take a red litmus paper and you dip it in acid, it's not going to change color. So if you dip it in a base, it turns blue only. That's how you know that. So going with our examples of this, I'm going to start with the weak point. Again, pure water is neutral. So a level 8, 100 times stronger than that, is going to be seawater or ocean water. The ocean is slightly basic. Baking soda is a base. It's a level 9. Notice we're getting into things that clean. Milk of magnesia. This is what a medicine that you can take. You can get it in the store. It's going to help with basically having an upset stomach where you have too much acid. Ammonia is a cleaner. That's going to be an 11. Notice we're getting stronger and stronger, 100 times stronger every time. Soapy water is a 12. Bleach is a 13. Notice you guys know that bleach is very strong and it can damage your skin if you're not careful. And drain cleaner, things that you pour down the drain to eat up the hair clog or anything else, is going to be so it's going to be a level 14. And those are things, there's lots of warnings on that label. You don't want to get it on your skin. Okay, so those are bases. So again, if you need to pause the video to get any of this filled in, please do that now. On this side, we're going to have stronger bases headed towards the bottom. We're going to have more hydroxide ions, OH minus ions formed. Okay, you may hear the buzzing. I'm in my classroom. So again, headed towards 14, we're going to have, these are going to be stronger in this direction. Okay. So your questions over here that you need. Saliva has a pH of 6.8 and turns blue litmus paper red. Saliva would be considered very basic, slightly acidic, very base, very acidic, slightly acidic, very basic, slightly basic. So take a second and think about that. So we said that neutral is a level 7. So if I'm talking about saliva, 6.8 in the 6 range, which is very, very close to 7, that means it's going to be in the acid section. It's in the 0 to 7 part. But it's close to 7, so it's only going to be slightly acidic. That is the answer to that question. Okay? And then you're supposed to take these guys here and arrange them from least basic, basically weakest to strongest. So if we look over here, we basically have the answers. So the one that's going to be the weakest, ammonia, bleach, baking soda, or soapy water. So I start at the top, which is where the weak ones are. I come to baking soda first. The next one that I come to, milk of magnesia is not on the list. Ammonia is on the list. That's next. Then, after ammonia, we get to soapy water. And the very last one we get to is bleach. That's on our list. Drain cleaner is stronger, but it's not on our list, so we're not worried about that right now. And there you have the very basics of acids and bases. Okay, so looking at the whole scale, one last thing I want you to think about is what would happen if you mixed a very strong acid and a very strong base together. Not all chemicals should be mixed, so what I want you to think about is the fact that if we have a strong acid and the opposite is a strong base, they're basically going to cancel each other out. So what that does is that creates a salt. It creates water as a byproduct, and it also creates a salt. Not the salt you put on your French fries. There are different chemicals that are known as salts, but is the result of a reaction between an acid and a base. If you mix, again, a level 4, that's 1, 2, 3 spaces away, 1, 2, 3 spaces away with a level 10, they would also equal each other out. I could also take a strong acid and mix it with, like a middle acid and mix it with a very strong base, and it would bring the level down a little bit, and it would cancel it out some, but not all the way. So they do have opposing power, just like multiplication is the opposite of division in math. So just think about those things. We're going to be using them in class, and make sure your notes are filled in, please.